Okay, it looks like this function has kind of been stretched a little bit vertically and translated vertically as well. So if the original function is sine of x, we know that sine, the amplitude is 1. So right now our maximum is going all the way up to 6 and our minimum is going to a negative 2. So the distance between 6 and a negative 2 is 8. So my amplitude is exactly half of that. So the amplitude is 4. So my amplitude is 4. Okay, so at exactly 4, that's our kind of our center point. So if I come down here at 4, that is my center point. So if I've got 4 units above it and I've got 4 units below it, your center point needs to be anchored on 0. That's where we're anchoring the center point, and it looks like it's been shifted up 2 units. So my vertical shift is a positive 2. We need to know 4 things. We need to know the amplitude, the vertical shift. We need to know probably the period. The period, it usually starts from 0 and goes to 360, and that makes one cycle. So let's start it here at 0. So pretend this is like a roller coaster. So you're kind of halfway up. You get on halfway up. You finish the climb, then you go all the way down, and then you start to climb back up, but you got to stop halfway. So right there, that is one period, and it went from 0 to 2 pi, which is 360. So the period did not change. Period is still 360. And okay, your phase shift, the horizontal shift, left or right, sine, you've got to know what the parent function of sine looks like. The parent function of sine starts at 0 and goes up at 1, then comes back to 0, then goes down to negative 1, then comes back to 0. That is the parent function of sine. So if we were to slide it like 90 degrees to the right, then it would come like this. So it would be at 0, it needs to start at 0. If it does not start at 0, so like my red one, if this were to start down here at negative 1, then that means it's probably been slid left or right. But my 0, it does start at 0. It just was shifted vertically up twice. So on these ones, I'll give you no phase shift. The phase shift will always, I'll just keep it put, it'll stay put, because that's too hard to determine the phase shift by looking at a graph. It's easy to tell the amplitude, and it's easy to tell the period, and it's easy to tell the vertical shift, but it is pretty hard to tell the phase shift, so that won't be on the test. So if you know your amplitude is 4, your vertical shift is 2, and your period is 1, your function is going to be y equals 4 times the sine of x plus 2. So the model, your model is y equals a times the sine of b x minus h plus k. So addition at the very end, that's vertical shift. This addition or subtraction in the parentheses, that's what's your horizontal shift or your phase shift. This number that you multiply before the parentheses, that's your period. And then this number, or it affects your period, and this number right here is your amplitude. So, number 2, how about this one right here? Okay, this one, the max is up at 3, and the minimum is down at 1. So I'm going to find my amplitude. My amplitude is halfway between here. And I'm just going 1 unit above, 1 unit below. So my amplitude is 1. They did not change it. The vertical shift, I think it's been shifted up. So we need to take all these dots back down to 0. Take that down to 0. Take this dot down to 0. Take this dot. Take everything down. Your vertical shift has been up twice. And your period has been changed as well. So here's 360. This is 360. And it should go through one cycle from 0 to 360, but it looks like it's been kind of compressed horizontally. It's been pushed together. So I start at 0, I go down, and then up to the top, and then back down. That is one period, because now I'm halfway back down the roller coaster. So that is one period, and it looks like I am getting in to 360. I'm getting in 2 of those. So my period from start to finish is 180. So my period just got cut in half. So how that shows up in the function is this. So the amplitude is easy. Amplitude is 1, and you don't even need to put it, times the sine. Now b, this is going to affect my period of x, plus 2. Okay, your period is always 360 divided by b, whatever b is. So in this case, my b must be 2, because 360 divided by 2 is equal to 180, and that is the period from start to finish. It starts and stops, takes 180 degrees for it to cycle through. So my b must be 2. So when it is a whole number, it's compressing it. But if it's a fraction, then it's stretching it out like this one below. So your function is y equals the sine of 2x plus 2. But there's one more thing that's kind of tricky but important. If you compare this with your parent function, so my parent function starts at 0, and then it goes up to 1, and then back to 0, then down to -1, then back to 0. Your sine function always goes up and then down, but this one right here, it starts and it goes down and then up. So that can show up in one of 2 ways, either a negative out here or a negative right here. But there has to be a negative, because the negative flips it. And this has been flipped because it starts and goes down. So this one looks like it's upright because it starts and it goes up. And it goes up to 2. That's my maximum. My minimum is a -2. And it is halfway on 0, so it has not been shifted vertically. It has just been, the amplitude's been changed, and it looks like it's been stretched out horizontally. So your amplitude is halfway between your min and your max. So the distance between your min and your max. My max is 2, my min is -2. That distance from there to there is 4. So it's half of that distance. My amplitude is 2. So it's going to be y equals 2 times the sine of something. Okay, now the k is 0. There's not a k, there's no vertical shift. And there's no h, because I'm not going to give you a phase shift. So let's find the period. Let's find b. So the period, you're going to go up to 1, down to 0. -1. Right there is one rotation. That is one cycle. So that cycle started at 0 and it ended at 720. then it usually starts at 0 and ends at 360. So your period has been affected, and your period has been stretched out. Kind of the opposite of the one above. It's been stretched out. So my B, 360, how did 360 turn into a 720? I divided it by 1/2, because I really times it by 2. So 360 times 2 is 720. So that means my B is 1/2. So the sine of 1/2 x. Okay, now we got a graph. So the parent function, cosine of x. Okay, now cosine is a little different. Cosine starts at 1. And it ends at 1. And then halfway through, it bottoms out at a -1. So it's going to go from 1 to 0 to -1, back up to 0 to 1, and then it's going to turn around and start over again. So that is my parent function. Now it's been transformed kind of in a lot of ways. The amplitude has changed, the period has changed, and this is your phase shift. Everything has been shifted 90 degrees to the right. Alright, so a good place to start. There's no vertical shift, so at least there's no vertical shift. But that's actually pretty easy. That's not too bad. So if I do this in pencil, there might be a couple dots, and then I'm going to move the dots. I'm going to erase. So your amplitude right now is 2. So that means I'm going to go up to 2, and I'm going to go down to a -2, and I'm going to go up to 2. So the amplitude is taken care of. Now, let's do the period. This period, so I'm going to take my 360 and I'm going to divide it by 2, and that is 180. So now I'm not going from 0 to 360, I'm going to go from 0 to 180. So I need to start and stop at 0 to 180. So that means this. That means this dot right here needs to be scooted over to 180. This dot's going this way, because that's my ending point now. And this dot needs to be scooted over to 90. So I'm scooting this dot. Now I'm going to erase those dots. So the colored one is probably easier to do in your parent function than the pencil in the one that's transformed. Okay, so this is it. That one is done. Now, this 90 degrees to the right, I need to shift every dot 90 degrees to the right. So this dot goes over 90. That dot becomes that dot. This dot becomes that dot. This dot goes 90 to this dot. So here we go. Now I'm going to erase. And my graph is now going to look like this. And then if it keeps going, it's going to just come back down, to turn around, come back down, go back up, etc., etc. Okay, now if we're looking at functions in an equation form, can you identify the amplitude, period, phase shift, and vertical shift? So here we go. Y equals A times the sine of B times X minus H plus K. Now an important feature is this coefficient of X needs to be 1. So this one is good. The first one is good. But the other two are not good. Okay. Now this is the exact same thing as 1/2 times the sine of 3x. So 3x is the same as 3 parentheses x. This is my amplitude. So my amplitude is 1/2. Check. The period, this is not my period, but it's gonna affect my period. My period is 360. I'm gonna divide it by 3. And then my period now is 120 degrees. So it's gonna start and cycle through and stop at 120. Check the phase shift. There is no addition or subtraction in the parentheses. There is none. And the vertical shift, there is no addition or subtraction. So there's none. And that's the first one. Okay, the second one. 4. Okay, that's my amplitude. But my coefficient of x is not 1. I need to manipulate this a little bit. I need to factor this 2 out. I need to divide both those by 2. So that is exactly the same as 4 times the cosine of 2 parentheses x plus pi over 2 minus 4. And this is the way it needs to be. You need to have a coefficient of 1 in front of your x. Okay, now my amplitude is 4. My period is 180. That is my b, and divide 360 by 2, so my period is 180. This is my phase shift. This is 90 degrees. So everything has been shifted 90 degrees to the left, because that's actually minus a negative pi over 2 is what that is. So everything's going left 90 degrees. And then this is my vertical shift. Everything's going down 4. All dots transformed, translated down 4. Okay, the last one. This negative is not going to affect my amplitude. It's just going to flip the graph over the center, over the middle of your max and min. So my amplitude is just, it's 1. It's going up to 1 and it's going down to negative 1. But I need to write this as negative sine of 3 times x minus 2 pi plus 1. So my amplitude is 1. My period is 360 divided by 3. So my period is 120. My phase shift is 2 pi to the right, or 360 to the right. So that's kind of what I was saying at first. If you shift dots 360 degrees, you don't see that. You cannot see that. So if I, for example, if I've got my graph, well, it looks like this. So there's a dot, there's a dot, there's a dot, there's a dot, there's a dot. If I shift this dot over to 360 and this dot over to 360, it's still gonna, you're not gonna see at all that it has moved anything to the right or left. So my phase shift is 360, and then my vertical shift is up 1. Alright, now we get into the probability. So this first one is an example of the fundamental counting principle, which is super important probability because it's used in everything. Permutations, combinations, all sorts of stuff. So, how many different types of genes are there? There's 9 different brands, and each brand has 5 cuts and 4 colors. The counting principle says multiply all your options 9 times 5 times 4. And what is 9 times 5 times 4? 180 different types of genes you can choose from. Okay, the next problem. For a graduation party, Lisa can invite 5 of her 15 classmates to go to a water park. So what are the chances that randomly she chooses those 5 kids. So this is actually a combination, because the order of these kids doesn't matter. So her first option, she's got 5 to choose from out of 15. But then second, she's only got 4 left to choose, 4 spots to fill. So she's got 5 spots to fill out of 15 kids, 4 spots to fill out of 14 kids, 3 spots to fill out of 13 kids, 2 spots to fill out of 12 kids, 1 spot to fill out of 11 kids. So you can do like this. And then if I'm going to cross cancel 5 15s, that's 1/3, and a 3 is going to cancel that 3. This 4 cancels that 12, turns it into a 3. This 2 cancels this 14, turns it into a 7. So on top, the chances are 1 out of 7 times 13 times 3 times 11. 7 times 13 times 3 times 11. So that's 3,003. So there's 1 chance out of 3,003 chances, or options, combinations. These are the combinations right here. So the formula to calculate the combinations. Alright, on top, we're going to put 15 factorial. On the bottom, we are going to do 15 subtract 5 factorial times 5 factorial. Alright, so if you punch that in, 15 factorial divided by 15 minus 5, so that's 10 factorial. And then divide that by 5 factorial, that gives you 3003. So there's 3003 combinations. So what are the chances she chooses these 5 as one of those combinations? So it's 1 out of 3003. Okay, the next one. A teacher randomly assigns her 30 students 4-digit ID numbers. She's using the digits 0 to 9, so she's selecting from 10 digits. No digits are repeated, so that's the big deal. So if she cannot exist a 9999 for an ID number. Okay, what is the probability that one of the numbers is 9,876? So this is definitely a permutation, because the order matters. So what are the chances that this first slot is a 9? And she's got 1 9 out of 10 numbers to choose from. What about the second slot being a 9, 8, a 7, and a 6? 8, there's only 1 8 in there, but now there's only 9 numbers to choose from. The 7, chances she chooses that 7 third position, there's 1 7, but now there's only 8 left. And the chances she chooses 6, there's 1 out of 7. So I'm going to take these and I'm going to multiply them. So 10 times 9 times 8 times 7, and that will give me the permutations. 10 times 9 times 8 times 7. So there are 5,040 permutations to choose from. And she's only got 30 kids in her class, so she's got plenty to go around. But what are the chances that one of the kids get this? And there's only one of those out of the 5,040 outcomes. Okay, the next one. Kayla and Bianca each bought 1 raffle ticket at the school fair. If 50 tickets were sold, what is the probability that Kayla bought ticket number 7 and Bianca bought ticket number 10. So this is kind of a permutation. The order matters. It matters that Kayla gets 7 and Bianca gets 10. So Kayla gets 7. And Bianca chooses 10. Alright. There's only 1 7. So if she goes, let's say they're like the first 2. Now this might be an ambiguous question. You don't know if they were the first 2 to buy the tickets or the last 2 or what. So, if they're the first 2, Kayla, there's 1 7 in there and there's 50 to choose from. But now Kayla goes next and she has to get a 10. And there's only 1 10 in there, but now there's 49 to choose from. So, if we do 50 times 49, there's only 1 chance out of 2,450 that Kayla's going to end up getting the 7 and Bianca's going to end up getting the 10. So I've got to tell you that they were the first 2 girls to buy tickets. Or do I even have to tell? I don't even think I have to tell you that. I don't think I do. So listen. There are, forget all the other kids. If I am only concerned about these 2 girls right here, I only care that, so yeah, the orders of them drawing doesn't matter if they're first or last. Because there are 2,450 different permutations to choose from these 2 girls. Choosing the numbers 1 through 50, there's 2,450 options that these girls can get tickets. One of these options, the girl could have drawn a 50 and the other one could have drawn a 49. She could have drawn a 50, she could have drawn a 48, 50, 47, 50, 46, and you keep going through all these options. So there's going to be 2,450 of them because she's got 50 options to choose from and then she's got 49. So of these 2,450 options, which one of them is the one that where she gets a 7 and she gets a 10? And there only exists one of those outcomes where she gets a 7, she gets a 10, but there is a total of 2,450 outcomes. Okay, this next one. If you randomly selected a permutation of the letters, so like these are Scrabble letters all mixed up in a bag, and you're choosing at random, what is the probability that you're going to spell? So G is your first, that's your second, you got to do them in order, and it spells geometry. So in that bag, 1, 2, 3, 4, 5, 6, 7, you got 8 letters to choose from. What are the chances the first one is a G? 1 out of 8. What are the chances that the second one is a E? So the G is gone, but now the E, you got better chances of drawing an E because there's more E's in the bag. So there's 2 out of 7. One of the E's is gone. What are the chances you're going to get an O next? 1 out of 6. Then all the letters, there's no more doubles. E was the only double. 1 out of 5. 1 out of 4. 1 out of 3. 1 out of 2. And 1 out of 1. So this 2 is going to kill this 2. So 8 times 7 times 6 times 5 times 4 times 3 And that is giving you 2,160 different outcomes. But only one of those outcomes spells geometry. Okay, the next one. The 5 starting members of the basketball team are lining up for a pitcher. What is the probability that they are lined up shortest to tallest? So the order matters, and this is the total permutations. Shortest to tallest, you've got 5 to choose from for the first spot, 4 to choose from for the next spot, 3 to choose from the next, 2 and 1. So it's just going to be 5 factorial. 5 factorial will give you all of your different outcomes. And there are 120 different outcomes. So what are the chances that they lined up with this outcome? Shortest to smallest, shortest to tallest. It's going to be 1 out of 120. Okay, the next one. If there's 25 kids in Mrs. Osborne's class, she chooses 3 students randomly to run an errand. How many different groups of students are possible? Okay, this one's going to be a combination, because the order of those 3 kids doesn't matter. Jim and Tom and Sue is one group. That's the same group as Sue and Jim and Tom. So the order of the kids doesn't matter. So she's got 3 out of 25. She's got 3 spots to fill. 2 out of 24 and 1 out of 23. And that is kind of the same thing as using your combination formula, which is 25 factorial divided by 25 minus 3 factorial times 3 factorial. So if I cross cancel this way, that's going to turn that into an 8, and then that's going to turn that into a 4. So 25 times 4 is 100. I think I just lost my marker. So 25 times 4 is 100, and then 100 times 23 is 2300. So there are 2300 different groups. What are the chances that she chooses Bill, Jim, and Tom? That's one of the 2300 groups. So this one right here gives me 2300. If you type this in on your calculator, 25 factorial divided by 25 minus 3 factorial times 3 factorial on the bottom, that gives you 2300. Okay, the next one. Suppose there are 800 runners competing in a 400-meter race. The fastest 3 runners win a ribbon. How many ways can they finish first, second, and third? So first, second, and third. So how many ways can you fill that first place winner? And there are 8. How many ways are there to fill the second place? Well, if you've chosen 1 for the first, that means there's only 7 left to choose from for the second. And if you've chosen 1 for first and 1 for second, there's only 6 left to choose from the third. So if you times it, 8 times 7 times 6, multiply your options, kind of like the counting principle. 8 times 7 times 6, you get, there are 336 different ways you can arrange a first, a second, and a third place finisher from a group of 8 kids. Okay, the next one, the family of 5 is sitting around a table for dinner. How many different ways can the family members be seated? Okay, now you need to disregard the chairs. So they're not talking about if the dad ends up in his favorite chair. They're talking about who he's seated next to. So the people, how are the people arranged? So if you've got 5 chairs all sitting around the table, this first spot, if I put the dad here, it does not matter which of the chairs he is seated in. So the chair arrangement doesn't matter, it's the people, how they're arranged, that's what matters. So he doesn't count. Now how many people do you have to choose from to sit on his right? You only have 4 people. Then you only have 3 people. Then you only have 2 people. Then you got 1 people. So if you multiply these, it's 4 factorial. 4 times 3 times 2. So there are 24 different ways you can arrange the people at that dinner table. Okay, this is permutation. So 7 is the N, 4 is the R. So you got 7 people to choose from, and you're going to choose 4 of them. So 7 permutation 4 is the same thing as 7 factorial over 7 minus 4 factorial. And what is that? Let's see. That's going to be 840. Okay, now these are combinations. There's 8 people to choose from. You're going to choose 5 of them. 7 people to choose from. You're going to choose 3. So you got to calculate this one first, and then this one, and then multiply those answers together. So if you do combination N is 8 and 5 is R, it's going to be 8 factorial over 8 minus 5 factorial times 5 factorial, and that gives you 56. And the next one, if I set up that formula the same way, the next one gives you 35. So if I multiply 56 by 35, I get 1960. Okay, the next ones is what we just barely left off. Tell if they're mutually exclusive or not, and then find the probability to the nearest 100. So selecting a number from a list of integers 1 to 20 and getting a prime or an even, and the primes are 2, 3, 5, 7, 11, 13, 17, 19, or an even, and that first prime is even, so these are not mutually exclusive. So the chances of this happening, so the primes, chances of choosing a prime, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 20. The chances of getting an even are 10 out of 20. So the chances of doing that or that, I'm going to add my chances together, but I've got to subtract this one that was counted twice in both groups, so subtract 1 out of 20. So my chances of this happening are 18 minus 1, 17 out of 20. Change that to a number to the nearest hundredth. 17 divided by 20. You got 0.85 or an 85%. So it's actually pretty good chance that's going to happen. Okay, the next one, drawing a card from a standard deck. In a standard deck, there's 52 cards. There's 13 hearts, 13 clubs, 13 spades, and 13 diamonds. So the chances that you're going to get a queen, there's only 4 queens in the deck, so 4 out of 52. Or a heart, there's 13 out of 52. But there does exist a queen that is a heart, so you gotta minus that queen of hearts that was counted in both groups. So this one is also not mutually exclusive. So 4 plus 13, 17 minus 1, 16 out of 52. And that gives you 31%, or 0.31. Okay, last one. According to the table, what are the chances that you're going to choose a kid that belongs to a club? What are the chances this kid's a junior? So, I can't remember what all those kids added up to, so give me a... Okay, there's 100 total kids in there. So the chances you're going to choose a junior, there's 39 juniors, so 39 out of 100. So 0.39. But what about the chances of that kid being a junior or on the French club? So the junior is 39 out of 100. The French club, we've got a total in the French club, we got 11 plus 15 plus 13. So that is 39. So there's 39 out of 100. But these were counted twice, so we got a minus 15 out of the 100. So 39 plus 39 minus 15, it's going to be 63 out of 100, or 0.63.